In part 3, we talked mostly about ionic compounds, and now in part 4, we're going to be talking about covalent or molecular compounds. Dihydrogen monoxide, safe or not? So right now, we can tell right away that this is different than the naming process before. Why? Because we have these prefixes before the names of our atoms that are bonded together. Dihydrogen monoxide, hopefully we figure out that that's H2O. Why can't we just call that hydrogen oxide? Why do we have to have those prefixes in there? The reason is because hydrogen and oxygen can combine to also form H2O2. Hydrogen, we're going to call that peroxide. We could also call it dihydrogen dioxide. But again, it's the same elements combining in a different ratio. So when we're talking about covalent or molecular compounds, we need to use prefixes. We'll get into that in a second. Covalent versus ionic. Ionic, we just went through, I give, I get. Meaning, the metals, they want to give up their valence electrons. The nonmetals want to gain valence electrons. So the metals give their electrons to the nonmetals. When they do that, charges are formed. Since electrons are negative and metals give away some of their negative charges, they become positive. Since nonmetals gain negative charges, they become more negative. Both ions are then attracted, cation and anion are attracted to each other, and they'll form a bond. Covalent bonding, or molecular bonding, we could think of as cooperating. Both the nonmetals share their valence electrons, so they all end up with a full outer energy level. We're not going to talk too much about how they share them right now. Instead, we're just going to look at formulas and look at names and looking how to recognize that it's ionic or covalent. So, how do we decide? We've talked about this before. If there's a metal bonded to a nonmetal, it's ionic. Real simple. If we have a metal in there, it's going to be ionic. If we have all nonmetals, we have covalent. I should say also with ionic, if we have any polyatomic ions, then it's also ionic, which makes sense. If it has ions in it, it has to be ionic. If we're just given a name, we look for prefixes. If there's no prefixes, then it's ionic. So like aluminum chloride or copper 2 nitrate. None of those have prefixes. Those are both ionic substances because we have a metal bonded to a nonmetal or a polyatomic ion. If we have prefixes in the name, then it's covalent. All right. So what is a molecule? Just a neutral group of atoms joined by covalent bonds. They cooperate or share their electrons so they can all fulfill the octet rule or just have a stable outer energy level. Here's a couple of examples. We have H2O, common to us, water. We have carbon dioxide, carbon monoxide. All right there we see the difference in prefixes, dioxide versus monoxide. And here we have a sugar molecule. Again, carbon, hydrogen, oxygen, 3 nonmetals, all bonded together, all sharing their electrons. All right, so naming. We've gone through the naming process for ionic compounds. They have a set ratio. Depending on their charge, there's no options. Na is +1, Cl is -1, so it must be a 1-to-1 ratio, NaCl. Na2O. Again, Na is +1, O is -2. It has to be a 2-to-1 ratio. But for covalent, we can get different ratios. So what we need is a way to name that we can easily distinguish between the different compounds that are formed. The example that we already talked about is carbon dioxide and carbon monoxide. All right, they have different names, they have different number of carbons, different number of oxygens. Hopefully we know that mono means 1. So CO, carbon monoxide, means 1 carbon bonded to 1 oxygen. Carbon dioxide, 1 carbon bonded to 2 oxygens, so CO2. Here are the prefixes. Learn them. They're not hard. You know most of them already. All right, we've already said we know mono, that's easy. Di is 2. Tri is 3. Tetra is 4. We've all played Tetris before. All these shapes in Tetris are made out of 4 blocks put together. That's where they get the name tetras from. Penta, pentagon, you think of 5-sided. Hexa has the X just like 6. 7 hepta, 8 octa, octagons and octopus, the 8 arms. 9 is nana, has almost the name in it. 10 deca. A decade is 10 years. Deca, real easy. So we should know these prefixes. They're not difficult.